There we go. We are live now. I did it again, and I knew it right when I opened up the thing yesterday that I forgot to record yesterday's Zoom with, and we had two or three of your compadres joined us in the class. So what I wanted to do was walk you through what this lab is. It's a simulated lab. It's kind of I think. I mean, it's a good thing that the PhET simulator, the physics educational, I don't know what T stands for, not testing, teaching, physics educational teaching or teacher thing. Anyway, has this through the University of Colorado has this set up, and it's a nice feature, and it's free, and so that's what you're going to log into now. Lab. The lab portion has two parts. It's the part A, which is just learning how to use the moving man thing, which is what you see here on your screen and on my screen. And the second part of the lab is you'll download these worksheets, and there's like 11 of them. And I know that seems like a lot, but there's only like 4 graphs that you're going to analyze on each one. So that's why it takes up a lot of space. All right. And I just want you to do the best that you can. All right. So without further ado, let me go ahead and let's go to, so when you download part A, here's what it looks like. So let's go ahead and maximize my thing here, and I'll probably cut this short. I might make 2 movies because I've got a class in 20 minutes, but I think we can get through this in 20 minutes. So what I'm going to be doing is I'm just going to be following along, and I'm not going to be bouncing back and forth. I don't think. I think it might be okay. Okay, so watch the Panopto dated on simulating the moving man simulation. I don't think that's there, so you're going to watch this one. Okay, and then you open. Here's the web page where you open it, and then let's just go there. So let's just go there, and I'll be reading from this sheet while we're doing it together over here. Okay. So I'll go to charts. Let's go to charts, and here's where you're going to be able to analyze the graphs. So let's change this acceleration too. And I wonder if there's a way. Oh, no. I want to add the acceleration back. I screwed that up. All right, so this acceleration is way too high. So let's get it down, way down. That's one thing we need to do. All right, first thing you need to do is set your acceleration, and I'm not sure if we can get, and that's about as low as we can go. Let's just put it here because we're not going to go any faster than that. All right, so set your acceleration down here. All right, and we're going to set the acceleration back to 0 here. In fact, to set it, let's just put it on 0. Press enter. There we go. Now I said to put the moving man on -8. And then you press enter, so you hit negative, and then press enter. Now he's at -8, okay? And, oh, no, I said put him at 2.0. -8, we're getting ahead of ourselves. So let's put 2.0, press enter. Boom, there he is at 2.0, okay? All right, notice we got this timer up here in seconds, all right? And then let's press the record button. And let's see what happens. Well, those graphs are going across. Doesn't look like a whole lot's happening. He's staying at 2 meters. There's no speed or velocity going. Velocity which has magnitude and direction. So it's positive and negative. And there's no acceleration, looks like. All right. Okay, so we'll clear all this. We just wanted to take a look and make sure everything's running across there, and it is. All right, so let's clear this, and let's clear this, putting back at 0. And I think, see, so we've already done the first 9 questions. All right, so it's not that intense. All right, And now let's take a look at so let's place the moving man at +8. Let's place him at +8, okay? And let's set the velocity, it says, at -1.5 meters per second. So it's set at 1.5 meters per second. Notice there's no acceleration. All right, so he's not going to be speeding up or slowing down during the thing. And we're going to see what those graphs look like. So let's run the simulation. So let's press the run the simulation for about 7 to 8 seconds. And here he goes. He's going the other way at a nice constant speed. Now, don't be confused by the graph here, because see, the graph is going to the right and he's going to the left. But look what's happening. So here we go. We've got I better turn off my I don't know how to turn this off. Sorry, you might see some text from my daughter. But anyway, notice he's going to the right. This is going to the right, but he's actually decreasing his position. It's going negative. Okay, so okay, hopefully she'll be done. All right, so anyway, talking about her morning run this morning to her dad. All right, so here we go. So he goes down, down, down. Let's run it for about, I'm going to run it for about 5 seconds. Okay, I hit it right at about 5 seconds. Right at 5 seconds. And notice his position is almost to 0. It's almost to 0. And if we go back to, and so if we make a sketch of his position graph, we make a sketch, we see that it's decreasing, and this is just your good old rise over run. Remember that from your 9th grade algebra or 10th grade algebra class, the slope of the line? Well, the slope of the line of his position, if there's no acceleration, the slope of the line tells us what the speed is. Okay, so if we take 0, so well, let's just, here I've done it. So let's just go to my ladybug here. And look what I've done. He started it, oh, this one ran for 8 seconds. Well, let's go ahead and run it for 8 seconds then. Let's go ahead and go back. Let's keep it going till 8 seconds. Notice he's past the 0 part and he's going in the negative territory, and the graph is going in the negative territory. And there, he's run for 8 seconds. And he is, oh wow, I stopped that at perfect. He's at -4. This will work great because when I go over here, so his initial position was 8, his final position was -4, his time was 8 seconds, and so his velocity, his speed, is just the slope of the line. If I take -4 minus -8, I get -12 divided by 8, I get -1.5. That's his speed. Okay? And so your current position, so if you were going to be filling out this chart, you'd be going, oh, my current position is -4 meters. My time is 8 seconds. And so divide the position, divide the change. Now this is confusing. I should have said divide the change in position. Like I did here, the change in position, -4 minus -8. This was something that I came up with when we had to go to online classes. I had other labs that I wanted to give you. Yes, it is. Okay. If yes, does this mean slowing down? No, he's not slowing down. He's just going, explain what the yes or no means. Because he's not slowing down. He's going at a constant speed, just in the what direction? All right. Is the velocity, and then we look at here and we go, oh, is the velocity changing over time? No. Is the acceleration changing over time? No. It's staying at 0. So now let's clear it and let's go on to the next one. What time are we? Okay, so we got a little bit of time. So let's go ahead and clear this whole thing. Clear. Make this 0. Make this 0. All right. Now, and okay, so let's place the man at -8 meters. So let's click into -8. Press enter. There he is. And then and let's set the velocity at +2. And let's set the acceleration. Oh, and uh, let's go for all right. So let's go. We set the acceleration still at 0, and then let's go for 4 seconds. I keep getting ahead of the thing, but oh, let's get on to the good stuff with the acceleration, right? But we're not quite ready for that. So here we go. So let's go to, let's start. Ready, set, go. And let's run it for about 4 seconds here. Wow, I'm getting pretty good at that. Almost stopped him at 0. Okay. All right. So again, here's his change in position. This is staying steady at 2 meters per second, and this is at 0. This acceleration still at 0. Okay. So what's our man's position at 1 second? So if he's going to go for what? So he's at -8, and he's going 2 meters every second. So if he's at -8 after 1 second, he should be at 6. After 2 seconds, he should be at -4. After 3 seconds, see, he should be at -2 because he's gaining 2 meters. He's gaining 2 meters every 2 seconds. That's what velocity means. Okay, now leaving the man in place and without hitting the clear button, let's change the velocity to 0.5 meters per second. And now this is going to cause something's going to happen here. And then let's press the button. Watch what happens down in the acceleration here. In fact, I'm going to make it even more dramatic. I'm going to change it to -1.5 meters per second. All right. Now watch what happens. Watch the acceleration. Boom. And then it stops. Do you see what happened there? Let's go in here. Then boom, he changed direction. If there's a change in direction, there has to be an acceleration because if there's a change in velocity, because remember, velocity has change and oh, this will be cool. Let's do it this way. Watch this real quick. Let's put him at -8. Boom. Oh, let's go ahead and clear it. Let's put him at, let's clear the whole thing. Let's put him at -8. There we go. And let's change this to +2. And let's have no acceleration whatsoever. And let's just do this. Here we go. So it's running for about 4 seconds. And in 4 seconds, he should be at 0. Boom, and he does cross 0 at 4 seconds because he's gaining 2. So now let's stop him here at about 2 meters. And now let's change the velocity to -2. There it is at -2. Now let's see what happens. Okay, he's turned around. He's changed direction. Boom! We have a huge change in acceleration. Notice, when there's a change in velocity, there has to be a change in acceleration because velocity has magnitude. In this case, the magnitude is 2 with a direction of -2. So he changed direction. The velocity changed. Whenever the velocity changes, you have a change in acceleration. Okay? All right. Now, let's go ahead and I'm going to walk you through real quickly what it looks like when you and then I'll go to the charts and stuff that we're to do. Um, and you'll just follow along one more time. You'll just follow along with what it says here. What do you think that means? How about, what do you think, Nimrod? If there's a change in velocity, there has to be a change in acceleration. Okay, now let's set him back at -8 and have set the velocity at the start equal to 0. And let's and I want to make this about a 1.5 meters per second acceleration so that we can actually see something. Okay? All right, so let's go on back. Let's set him again. Let's clear everything. Let's set him at -8. Boom. And this at 0. So there's no velocity. And let's change this guy to -1.5 meters per second squared. So what that means is, oh, positive 1.5. Oh my, I'd have him going completely the wrong way. 1.5, 1.6, 1.5. I'm trying to think if I should leave it. Now let's leave it at 1.5. Otherwise, he'll run right out of the picture here really fast. Okay, so I'll press enter there. All right, so this has popped up to 1.5. All right, and it's going to be a constant acceleration. But watch what happens. So after 1 second, how fast should he be going after 1 second? If he's changing his speed, his velocity, 1.5 meters per second every second. That's what meters per second squared means. It's meters per second divided by seconds. So if you remember the old, when you divide fractions, you flip and multiply. So that becomes up to meters per second squared. So after 1 second, he should be going 1.5 meters per second. After 2 seconds, he should be going, I heard you, 3 meters per second. That's right. Let's see if this is true. And let's let him, and he's probably going to run right off the page because he's going to be accelerating. And watch his position graph. Watch what happens with this position graph. Here he goes. Here he goes. Right now the position graph looks like it's almost a straight line, but it's not. Notice, it is a parabola. I don't want him to crash into the wall. All right. Notice his position, he's almost at 10 meters. Okay, that was a squared thing. Let's put him back at 10 and -8. Let's put him at -10, so he's got further to go. There we go. Now, same, and let's put this back at 0. And let's watch the same thing again. Oh. Let's make this 1.5. Okay, it put us at 4 seconds. It started at the 4-second mark. Notice all this, I don't know what I did. I forgot to set, I don't know what I did. Okay, I don't know why that didn't, but you see nice constant acceleration here. And then this is a straight line. Now all of a sudden the velocity is the slope of our, the slope of the velocity is the change in velocity over time, which tells us the acceleration. All right, so that's what we're doing, okay? And then, and I'll just spend about 1 minute on this, or 2 minutes. Then, so you're not afraid of it when you get it. Notice, when there's an acceleration, there's a parabola. And if he goes in the negative direction, it'll be a negative parabola. All right, so let's go and look at the, and here you go. What do you create? What do you do to create a horizontal line in the position graph? This is, we use motion sensors, and the people are actually walking in the lab. But right now they're using this. You guys are doing the 240, Physics 240 and 250 lab 1. Welcome to the big leagues. I know you didn't sign up for it, but you can do it. You can do it, and I think it's cool that you learn it. So by playing with this moving man to get started, you can see the different positions, and then how do we get that? How do you walk? So if you're the moving, if it's the moving, and you can go back to the moving man and go, well, how do I change this? How do you walk to get a straight line that slopes up? Well, you walk in the positive direction. Your velocity is constant in the positive direction. And here we changed. All of a sudden, we had a change in velocity. Boom. So, but this is this position over time graph. This is the x graph. All right. I think you'll be fine. I've never done the class like this ahead of time, and students picked it up. Okay. Oh, because I did have that one thing, but I need to change that. This is what you're going to be watching. All right. Okay. Out here. Now on to my next class.